we are starting the GTM, Global Traffic Manager,
Yes.
and also known as DNS module. So DNS is domain name server. So now you can see Big IP DNS version 14, right? So that's what we are going to start with. So first of all, I will explain you the topics that you are going to cover during this GTM training. And many topics were already covered. So I will skip all of them, right? If there is a topic that we already covered in LTM training, then I'm not going to like setting up the big IP system. We don't have to cover it over here.
Yeah.
We are already aware that how to set up a big IP, like
Yeah.
how to allocate IPs, then how to add route, so and so. So all those things are already covered,
Oh,
right? So I
yes.
don't have to do it again and again. Hmm?
Yeah.
And then chapter number 2, this is where exactly we have to get started. So basically, let me tell you in short, this GTM is going to work, this DNS module, right? Over here, the big IP will be working as a DNS server for you. The final statement about this big IP DNS, that it will be working as a DNS server. So when I say it will be working as a DNS server, which means that it will be responsible to resolve your names into their respective IP addresses, which means that you would be creating entries on big IP DNS that, hey, like this name belongs to this IP, this name belongs to that IP. So you will have to create all those entries. But it is a very different DNS server than the traditional DNS servers. Like obviously we had Microsoft DNS servers in past, we had Linux, we had some other DNS servers, solutions. But it is very different than those in many aspects, and that is one of the biggest reason that F5 does not call it just a DNS server, right? F5 calls it intelligent DNS server, right?
Okay.
F5 calls it intelligent DNS
Yes.
server, right? So it is not just a DNS server, it is an intelligent DNS server, right? So, and why do they call this DNS server as an intelligent DNS server? Because what you can do, let's say you have got multiple servers,
Yeah.
application servers, and you are accessing your application using a name. So obviously DNS server will be responsible to resolve that name into one of the application server IP, the backend IP. So the way big IP DNS works is like it will always monitor your backend servers. It will always monitor your backend server. And if it sees that, okay, this server is not online, is not available, then big IP DNS will never provide that IP address of the server which is currently down, right? Will never provide that in response to the DNS query. And that way, your end user will never ever try to hit that server which is currently offline, which is currently not available. So that way, because it is doing the monitoring, it can perform monitoring, and that particular feature was not available with your traditional DNS server, whether it is a Microsoft DNS server. So if someone is using just Microsoft DNS server, obviously they can resolve names into an IP address. You go and create the host entries on those servers, but those servers never monitor the availability of the backend application servers. But here in Big IP, you have got that opportunity that you can also configure the monitoring. And since you can configure monitoring, since you can configure the monitoring, and therefore you can expect that whenever an IP address is provided as part of the response is always online.
Yeah.
And that way end users will never face any kind of like outages or bad services, I would say. So now before we get into the big IP DNS, the objective would be to understand the DNS first. So we need to understand the DNS. So obviously, like we have to learn that how to configure DNS on big IPs. We have to
Yeah.
understand the DNS, and I'm pretty much sure that Roshan, you are already aware that what DNS does, right? What exactly DNS is doing in a real environment, especially when it comes to the internet. Internet is totally dependent over the DNS. Internet is dependent on the internet circuit. Obviously, the physical connectivity is needed, but on top of that, DNS is also one of the essential requirement for internet to work. So
Yeah.
let's assume that sometimes if the DNS goes down, let's say Google DNS goes down, and across the world there are many customers, or I would say many systems across the globe who are using that Microsoft DNS as their DNS server, like 8.8
Yes.
Google DNS, 8.8.8. Then Amazon has got their public DNS, which is 1.1.1. So
Yeah.
if those DNS servers goes down, then obviously internet will go down. And not only
Yes.
that, in fact, for the broadband providers like Airtel in India, or maybe Tata, or maybe Jio. So these all are the broadband providers in India. Now, since these all are the broadband providers in India, and the way that the broadband internet is set up is like the modem gets installed at your location. The
Yeah.
modem is given by the modem route. That modem router is provided by the telecom provider or broadband service provider. And then there is a DSCP pool configured on that modem. And that's how you connect your laptops to that modem using Wi-Fi wireless network. And then you get an IP address from that modem. But that is always a private IP. The public IP is assigned to the modem, and your modem does the netting, but at same time your modem is also working as a DNS server. Like in that DSCP pool, they configure that modem itself as a DNS server. So whenever your laptop at home gets an IP address from DHCP, it also gets a DNS server IP dynamically. And in most cases, it is your modem's IP address. Now, since it was a modem's IP address, which means that your laptop, whenever you will type any name in your browser, like www.google.com or yahoo.com or whatever, the request will be sent to your modem, the DNS request. Now, the modem is already configured with the forwarders, and modem is having the DNS servers which are hosted at service provider end. Like if you have got the broadband from Tata, then Tata will be having their own DNS servers.
Yes.
And if you have configured, like if you have a broadband service from Airtel, then Airtel would have their own DNS services or DNS servers, and those are configured on your modem so that modem can forward those DNS requests onto those service providers DNS server. Now, what if the service provider's DNS went down? Right. So in that case, whenever DNS request is generated by the lane user machine, it will be given to modem. Modem will try to forward it over to ISP's DNS server. But since the DNS is down, so name will not be resolved into respective IP address, and you would not be able to access the internet then. Hmm? Because
Yes.
even sometimes, what people can say is that you can note down the IP address in advance, like for your critical websites, like for facebook.com. I can obtain the IP address of the facebook.com, and we can try to access facebook.com using its IP, but it will not work because Facebook does not allow anyone to access their website using an IP address. They don't allow that because their website is secured by the SSL, I mean TLS, and they are using digital certificate. And as part of the digital certificate, the host name must match with their common name in the digital certificate. So in that case, the only option that they give you is to put the host name in browser, and that way the host name will match with the common name in the certificate, or maybe SAN field, subject alternative name, and then only
Yes.
connection will be allowed, the TLS connection. Like for an example, if you see here, if I type, let's say google.com over here, I can open up it in incognito. So that way we are more confident. So google.com. So this google.com has been loaded and it is a secure connection. You can see that there is a certificate.
But
Certificate is valid.
I have one thing in my mind, because
Yes.
nowadays we are not able to see in the bottom of the browser the IP address. But earlier in 90s or 90s or 2000s era,
You were
uh,
able to see the okay
yes,
IP address
there
is
is no
being
DNS
accessed,
IP
right?
address,
Yes, I
right?
get it. I get it. Yes.
Yeah.
Nowadays it is not there, but in backend it's always resolving name into an IP address,
No,
right? But it
that I agree, but nowadays we are not able to, because of the technology and because of the speed of the, I think
correct.
that we are using that.
But this is the IP address that we are getting, right,
Yeah,
from
yeah.
the DNS. So we can always get the IP address by pinging that domain, and then if you try to access that using its name, it will not be accessible. So that's the thing. Basically, when you ping a name, you always get
Yeah.
an IP address. But thing is, like, even you get that IP address, like I got this IP address here, right?
That is IPv6.
Correct. Right. So if I copy that and put in the browser, like HTTPS, and then if I put that IPv6 there, it's not gonna work. Even though if I get the IPv4, right? I can also get the IPv4 by doing like NS lookup, right? So if I look up www.google.com. So I can get the IP address of the google.com. So this is IPv4, and
Yeah.
let's try with IPv4 then, right? So if I say HTTPS, right? So nowadays no website is accessible using an IP address. See,
Yeah.
like it automatically converted into the name automatically.
Yes.
Which
Yes.
means that Google is doing something in backend to convert
Yeah.
or to change this IP into. But initially, if you saw that, if you observed that I got a certificate error message, and I had
Yeah.
to, and that's what happened. If you are trying to access with an IP address, and if you don't use the name, then you would always get the certificate error. And nowadays, sometimes we also make the settings in the corporate browsers. Like if you have got a corporate machine, we also change the settings for the browser that if there is this untrusted certificate, right? If there is a
Yeah.
untrusted certificate, do not proceed. Do not open that website.
Yes.
Correct. So in that case, you would not be able to access all these websites using their IPs, right? So that's the thing. So point is that the DNS is resolving names into an IP address, and it can also perform in reverse manner as well, right? I mean, it can also resolve your IP into name as well. So it depends like how we are trying to utilize it. But ultimately, that's the role of DNS, right? So now we will go for this DNS chapter number 2, right? And let's try to read or let's try to learn something about the DNS. But if you look at there, so we have got the introduction of DNS, and right after that, we get started with the DNS resolution using Big
Yeah.
IP. So we will have some labs as well, like how to set up your Big IP DNS to resolve names into the respective IP addresses. And that is what we will be doing. So like you would learn how to configure a listener, what is a server pool, how to
Okay.
get your DNS queries load balanced in case if you have got multiple backend servers, right? And then what is the caching, what is DNS Express, right? So all those sort
Yeah.
of things. And then we will start implementing the intelligent DNS resolution. This is one of the reason, this is one of the feature of the big IP DNS that we are using, we are utilizing this F5 big IP as a DNS server. So as I told you in the beginning that F5 does not call it just DNS server, they call it intelligent DNS server. And they have got, definitely they have got they have got the intelligence over here. We can monitor, we can do so many other things as well. That's where we will have some labs around the intelligent DNS resolution. If you roll down, then you have got some LDNS props as well to achieve your intelligent DNS resolution. So you can also configure the LDNS props and metrics, and that would work to collect the information based on which your big IP DNS can take the decision while resolving names into their IP addresses. Then load balancing intelligent DNS resolution. This is one another thing that we have got, load balancing intelligent DNS resolution, right? And then we have got monitoring, like how you can perform now this is the chapter that basically you already covered, right? Monitoring. So I don't really have to cover it again here during the big IP DNS training, because you know that how to create monitors and then how to get them applied, and in which case which type of monitor we should use, right? So we know about that now. And then finally, it is about the DNS security, like how to secure DNS request response. Like how, if you get a DNS response, right? How do you identify that DNS response is given from the DNS response is coming from the trusted source? What if somebody inspected DNS request in between and provided DNS response and with the incorrect IP, and now you are connected to a incorrect? Because see, DNS is also one of its kind of technology that can also be utilized for making the attacks. Like for an example, just for an example, right? Somebody simulated the HDFC Bank website, right? Like you access the HDFC Bank website here in India
Yes.
to make the banking transactions. So somebody simulated that, and now using DNS, like for an example, let's say I am trying to access the HDFC Bank website, right, for net banking, and somebody gave me the DNS response with their dummy website IP address, right? So I got
Mm-hmm.
the IP address from DNS. I'm trying to access the correct URL, but I got
Mm-hmm.
the attacker's IP address in the DNS response. Right now, obviously, I will not be able to recognize that. Why? Because the website is same, right? The attacker has created a duplicate website. I'll go ahead and will log in, and that's how the attacker might get my user credentials. Correct.
Yes.
This is like one of its way. So in that case, it is very important for us to have the DNSSEC in place. DNSSEC, because DNSSEC helps us to validate, to verify if this DNS response is accurate. I mean, is coming from a trusted source. Okay. So that's what DNSSEC does over here. And that's it. There is nothing more. It's just that, I mean, this is what we have. And that is the reason that we get this covered mostly in 2 weekends only, like in 4 sessions, maximum 5 sessions, not more than that.
Okay.
So these all are the labs, and this is the official content. I'm not like following my own content. So you know that setting a big IP, I don't really have to tell you that how to set up a big IP. You know, it works in full proxy architecture mode. That is basically in regards with the LTM functionality. So LTM is there, and LTM is by default working in full proxy architecture. And it can perform so many things, not only load balancing, but it can work all all the way through layer 7. Correct. And that is the reason that you are calling it full proxy. Deny by default, you know very well. This is the default behavior of the big IP. Correct. Like it's like a firewall.
Yeah.
If any traffic comes in, it will drop that until unless you explicitly allow that. Like we allow it by creating virtual server on LTMs, right? In case of DNS, it will be a listener. So you will have to create a listener. So if you don't create a listener on your big IP DNS, it would not entertain any of the DNS request. So if you really want your big IP DNS to entertain the DNS request, then listener has to be created. If there is no listener, then DNS request will be terminated. Make sense?
Yes.
Now, as I told you, within a big IP, you have got a single box, right, from F5,
Yeah.
a single appliance, and then single operating system, which is TMOS. But like if you have got like hardware and then you're running a TMOS operating system, within that TMOS, you can activate any of these modules, right? Like LTM,
Yeah.
DNS, Advanced WAF, APM, Secure Web Gateway, or maybe firewall mode. So it's up to you that which all modules you want to activate. Even on a single device, on a single platform, you can activate multiple modules, but especially with the DNS, it is not recommended to club that with LTM, right, sir?
Okay.
Any questions?
No.
Okay. So, I mean, it's not technically we cannot have LTM DNS on a same box. We can have that, right? But is not recommended. Like, let me tell you the combinations. So, whenever you talk about the ASM, which is WAF, Advanced WAF, and LTM, you would see the combination of LTM and Advanced WAF on a single big IP. Correct?
Yeah.
If you are looking for firewall module, then also you will get the combination of LTM and AFM. If you are not using, let's say, advanced WAF, and you just
Yeah.
want to utilize only firewall functionality, then you have the combination of LTM and AFM on a single big IP. Hmm? But I haven't seen
Okay.
any customer so far having LTM and DNS because those two are like totally different. Like
Yes,
obviously
I agree on that
firewall,
because yeah, I agree on that because both are different. We can
exactly.
say technology, and maybe because of that, uh, hardware is getting some kind of lacking in because of that because they are utilizing high resources of the
Higher
hardware.
resources as well as there is see if DNS goes down, LTM goes down,
Yes.
LTM goes down, DNS goes down, and LTM and DNS that like on configuring DNS does not require the LTM virtual servers, but if you configure the firewall module or you are creating the advanced WAF like
Yeah.
policies, then those needs to be bind with a virtual server, right? So obviously for those, having LTM module activated is mandatory, but with DNS it is not, right? DNS is totally different. DNS itself has got a terminology called listener.
Yeah.
It has got a terminology called listener. Well, management, you know how to allocate IP address on management interface of
Yeah.
the big IP and how to configure some other stuff like self IPs. So, and so these all are the resources, like where you can have all these things.
Yeah.
Big IP high health, or articles on onto Dev Central, right? You
Okay.
can read the articles, communities, forum is there. You can download iRules. You can get wiki pages. On Ask F5, you can download the manuals, best practices, non-issues, solutions, security advisories will be found under Ask F5, because they have got like different platforms for helping out their customers, right? So Ask F5 is one of them, Dev Central is one of them, and Big API Health is one of them.
Yes.
Okay, so askfi.com is like where you can get product manuals, release notes, non-issues, security advisories for the platforms, right?
Yeah.
Hotfix information. So all those things can be found over there. Then Dev Central is there, right? So the article, how to video and content to guide you through the configuration. So that can be seen on Dev Central portal. And IELTS is just to, like there is a feature called QKView. You can always download the QKView file from the LTM or DNS from wherever, and then you can upload it to your ihealth.fi.com.
Okay.
And they have got this portal to analyze the configuration of your big IP, right? And post analyzing, it will also provide the recommendations, right?
Okay.
So that's iHealth. But we don't really have to cover that. So big IP system confirm net. I mean, this is all you have you have already performed
Yeah.
that, right? I have to how to do this or that, right? We have got kind of similar topology. Like we have got a set of big IPs,
Yeah.
especially in case of the LTM, and so we have got all that kind of stuff. Also, let me just put it in this way. The DNS, evolution of DNS. Do I have to explain that?
No, no, no,
Evolution of DNS, right?
no, no,
Then
no, no,
hierarchy is like root DNS, and then we have got
no, no, no. Nothing,
the
nothing.
subdomains, right?
We'll start
And then
directly with lab.
exactly, we can start with that. But like sometimes I have seen people in networking industry that they have zero knowledge around the DNS. So when I ask them that, okay, what is root DNS? Have you heard about the root DNS in past? They says no. Or have you heard about the subdomains like .com, .edu? So they says no. I mean, we don't have any knowledge around that, right? But it is, these are the basic stuff which comes from this DNS technology. So
Yeah.
I mean, it is always good to have the knowledge around the DNS at least at this level, right? So root, there are many root servers, and
Of
all
course.
of the root servers are hosted in US. Some of the root servers are hosted in some universities, and some of the root servers are hosted in their defense network, right?
Organization.
Yeah. So, but root servers, all of the root servers are managed by United States. All of them
Yeah.
are hosted in United States, and there are many root servers. And fortunately, unfortunately, your system, I mean, especially the DNS, Windows DNS server. So Windows
Yeah.
DNS server knows very well that who all are the root servers. It's pre-configured in their operating system. Okay, you
Yeah.
don't tell your Windows DNS server that who all are the root servers, right? And then we have got the first level domain, right? Even for first level domains, there are um, like there are servers
Yeah.
managing all the entries for. So root server will have information about each and every first level domain, also known as subdomains, right? Like
Yeah.
.com, .edu, .net. So now there must be a server who contains the information about all the domains ending with .com, right? So that would be .com subdomain. And then you
Yeah.
have got .edu, .net, .org, .gov, or something like that.
And more on means there is many more over there.
There are many more, right? It's just that we have kept a couple of entries over here, and that's
Yes.
what we could write in this diagram. And then that's where the f5.com, or like all these things comes up, and you call them subdomains, right? So the .com, .edu, .net, .org, .gov, these are known as TLDs, top level domains, right?
Yeah.
TLD. So there are many TLDs across the globe, many TLDs. All
Yes.
TLDs have their IPs, and again, like Windows DNS server or maybe Linux DNS server, they know In fact, they don't really have to have the TLD's information because that would be provided by the root domain, right?
Yes.
So I will explain you that how the DNS resolution works, right? But point is that this root will have the IP addresses of each TLD, and then each TLD like .com, this .com server would host or would keep the database for all .com websites or subdomains, all of the .com subdomains, and then .edu TLD server will maintain the database of .edu subdomains.
Yeah.
So that's how they will keep. And then F5.com probably, now if you want to host your domain, right? So there are multiple steps that you need to take. One, you have to decide that where do you want to host your DNS server. Do you want to host your DNS server by your own, or maybe you want to give it to somebody else? Like there are many providers from where DNS service provider, right? From where you can purchase the services, correct? Like they can host your domain on your behalf, right? So you don't have to have your internal DNS server. Like for an example, you have got a website. If we have got a I-MEDITA website, I-MEDITA.com. So if we have got that I-MEDITA.com, and if we are saying that we need to host a DNS server and just for a single website, then we are full because we are spending too much on that, right? So better that we take those services from third party, correct,
Yeah.
to host our domain. And that's what we have done. But if we have got like maybe plenty number of domains, right? Plenty number of domain, then better that we have the in-house DNS services. So that can work. But even though if you are having a in-house DNS server services, at least you have to tell your TLD, you need to provide your IP address, your DNS server IP address to the TLDs. So for that service, you need to pay to your service providers, right? Because whenever they get the request for let's say for imedita.com, and I want that all the DNS requests for imedita.com should come to our network, right? Because we are hosting internally DNS server. So we need to inform the TLDs that if you get like the .com TLD should be aware that if they ever get any request for I-MEDITA.com, then they need to forward that request over to our DNS server, right?
Yeah.
Just like this. So if you talk about like DNS resolution, this is how it works. This is exactly it is going to work. So you would always have a local DNS server, right? And
Yeah.
that's exactly what you have got in this diagram. So let's say there was a lane user, and let's assume that this is your Windows server, right? This is your Windows
Windows.
server and Windows DNS server, right? So when you send a request to the Windows DNS server, either Windows DNS server can provide you response from its cache. If it's not available in its cache, then it will look for its records, right? Database, if it has any mapping for that name. If not, then finally it will go to now, tell me, root server. Now this Windows DNS server is already having an IP address of the root servers. So it will pick any of the root server and it will go to that root server that, hey, I need to have the IP address for this domain, right? So now root will find that, okay, it's for .com. So it will provide the IP address of the .com, not the fi.com immediately. And therefore, this local DNS does not need to have the database of, or does not need to have the IP addresses of TLDs, right? It does not need them, but it needed the IP address of the root name server, correct? Or root servers. And in fact, on your Windows DNS servers, you can see the list of the root servers. You can see that, right? You can open up like whenever you get a chance to work on the Windows DNS server, just look for the root servers, right? It can give you the list of the root servers.
Oh.
And then root server will provide the IP address of the TLD. Now you will go to TLD. You will go to TLD, which is top level domain. And this TLD will give the exact IP address of the DNS server, which is hosting that entry at www.fi.com. So let's say this name server or this DNS server is managed by the F5 only. But at least this information should be given to the TLDs. Then only TLD will be able to provide the IP address of the DNS server managed by F5. Fine. So now the request will be sent over to this actual name server now. And from there, you might get the IP address, right? Like this. And now this DNS server this Windows DNS, right, will also cache this entry and will send it over to the PC lane user machine. Finally, it will be able to connect with your application server, correct? Once it gets that IP address. So this is the whole process. So point is that your local DNS only needs to have the list of the root servers. And if it was a modem, let's say it's not a Windows server, it was a modem, then modem is always configured with the furthermore forwarders, right? Or DNS servers. Right? So it can forward that DNS query to the another server, another DNS server. And if you are using, let's say 8.8.8, so let's say this is 8.8.8, right? So you went to 8.8.8, you asked that DNS server. Now, if it has the answer, which is good. If not, then it will also follow the same process. Like it will first go to root. Root will provide an IP address of the TLD, and TLD will provide the IP address of the actual DNS server where that entry is hosted, right? So now to get yourself registered, because domain must be registered, right? And that's why you need to purchase the domain.
Yeah.
Right, so that TLDs can maintain those entries. So you need to purchase these subdomains like f5.com, cisco.com, I-MEDITA.com. And not only you have to purchase them, but also you need to inform your TLDs that who is the DNS server. Now, I don't think that you need my explanation around like each
No, no,
subdomain then will further
no.
have more, more subdomains, because again, it is also known as subdomain. Like within f5.com, you can also have like tag.fi.com, sales.fi.com, hr.fi.com, right?
Yeah, yeah.
And then within HR, you can also have the users like saurabh.hr.fi.com, right? And that's exactly called FQDN, fully qualified domain name.
Yes.
So that's that. Well, so this DNS resolution process is really important to understand. So obviously, caching and TTL values is always there. Like as I told you, like whenever the DNS response is given from the DNS server, this local DNS is going to cache that
Entry.
exactly. And the TTL, time to live, is like for how long it can keep that entry in its cache, and it is
Yes.
equally applicable for the end user machines as well, not only for the transit device but also for the end user machine.
With the TTL value, we know, means we are able to know that whether it is Windows server or Linux server, right?
No, with the TTL value, it is defined that for how long you can keep that entry, for how
Okay,
long
okay.
it is a valid entry. Afterward, it will get expired, and then you will have to make another DNS request then once it gets
Oh,
expired.
okay.
Yeah. So this time to live. So it's not in hops. It's in basically in seconds. By
Yeah.
default, I believe it is an hour, but you can always adjust that hmm,
Oh,
on your DNS servers. And then implementing big IP DNS. So as I told you that the DNS server limitation. So we had like Microsoft DNS server, right? They are functioning, which is fine, but they have got limitations. So the more significant issues arise with both methods, especially when multiple IPs are associated with single name, as would be the case if same service is disrupted at various different locations around the internet to facilitate redundancy. For example, such cases will select the IP address to respond with using round robin method only.
yeah.
Correct. So since they are always going to use that round robin method, what if one of the server goes down, right? Still they will keep using the round robin. Big IP DNS resolution will fix that problem. So it will keep monitoring the backend services, right? If it says that okay, one of the server is not available, then immediately it will stop providing that IP address in the DNS responses. And this is one of the reason that it is also known as intelligent DNS resolution. Now remember that big IP DNS can be used as an authoritative name server. So authoritative name server is like when you utilize your big IP DNS, like as I told you, like you are hosting your DNS services on your internal DNS server. So you have got a DNS server where the requests are coming from the internet, from
Yeah.
the internet, and you are resolving them. So that's what you call it as a. So that's the authoritative server. So authoritative server will be responsible to resolve your queries into to resolve your DNS queries into their IP addresses, right? For the request coming from the internet. So this is an example where the F5 big IP DNS is being utilized as a tell me authoritative server. And not only that, but also you can use it as a LDNS, local DNS, right? And at same time, it can work as a LDNS as well as tell me. authoritative server. Like a single big IP DNS can be configured as both LDNS as well as authoritative server. Now you can ask me how. So for an example, you have got an enterprise network where you have like more than 1,000 of users. So for all of them, you can have your DNS server directly configured your big IP DNS, correct? So which means that it is working as a LDNS for all those lane users within your organization. But also you created some host entries on your big IP DNS for the internet. Like you have got one public facing application in your data center, correct?
Yeah.
So if anyone is sending a DNS request for that application over the internet, then those DNS request is also coming to your big IP DNS, and big IP DNS is resolving them. So that means that your big IP DNS is also working as a authoritative server. And that's how exactly you get this deployed in the production environment. That at same time, for your internal users, for your corporate users, your big IP DNS would work as a local DNS, LDNS. But for the internet users, it will be working as a authoritative server. Make sense?
Yeah.
Good. So that's that. And now, for DNS resolution diagnostic tool, like we should be aware that we can use this dig command, and dig command gives you very, I would say comprehensive output, right? That you can utilize to perform troubleshooting, right? But the dig utility is not by default enabled on Windows systems, right? Ideally, this command is applicable for the Linux machines, not for Windows machines. And if you want to use this dig utility on your Windows machine, then you will have to get it activated. You will have to get it installed. But yes, it is doable. Ideally, we use the NS lookup on Windows machines, but NS lookup does not give you doesn't provide you the comprehensive, I would
Output.
say, yes, as dig does. In my opinion, the dig command is more relevant, more expressive, more important. But yes, if dig is not supported, then you can also you can also use the NS lookup. Like in most cases, we use NS lookup on Windows systems.
Means
We
most of the case means 99% people they are using NS lookup.
Exactly. So they don't use dig. You know why? Because the dig is not by default installed. Accelerating DNS resolution. So if you want to accelerate the performance of the DNS server, there are many recommendations that we could probably like. We can simply use this bigger, especially this feature like accelerating DNS resolution. This feature is used ideally to do the migration. Let's say you are now trying to migrate your existing traditional DNS server, Microsoft DNS server onto big IP DNS. And you don't want to disrupt your services during the migration. So that's where it will come into the picture then. What you can do, you can simply put your DNS in between. Like, let me see if I can find the diagram. No, I don't have the diagram, but let me show you one of the diagram. Let me log in here. Close F5 GTM. So if you look at here, right, I had like if you really look at my servers, I had a Windows DNS servers. These two are my Windows DNS servers. I'm placing big IP DNS in between them.
Oh,
So I don't want to disrupt my services, and I want to slowly migrate my DNS entries from the old DNS servers to the big IP. Correct. So I've just
yeah,
placed big IP DNS in between. In between. So
yeah,
all the requests now will go to big IP DNS first, and then they can be given to backend server. In that way, I can configure this big IP DNS. Like simply, it will perform the load balancing among both of the old or existing DNS servers, right?
yeah,
So that there is no service disruption, right? So to avoid that, you implement it in that way. But the point is that if you want to accelerate the DNS performance now with this solution, right? So you have got like multiple options. Like one of them is enabling caching here, right? So
yeah,
as soon as the DNS response is given by the backend server, that response will be cached by the big IP DNS. And in future, if it gets a DNS request for the same name, then the response is given locally by the big IP DNS itself, right? You don't have to go back to your backend server all the way.
yeah.
So caching is one of them to improve the DNS resolution process, or I would say performance.
Okay.
So caching is one of them. The second is DNS Express, where you just transfer the zone database. So obviously, you know that DNS server will always have the zone database, correct?
Yeah.
Where they keep the like host entries or whatever records you have created, right?
Yes.
So those entries are always kept in that zone database. So that zone database can be transferred from the Windows DNS servers to this big IP DNS.
Okay.
Correct. So that's that. And as soon as that zone database is available locally on this big IP DNS, if any request comes in, it can provide the response back immediately. And that would also protect, like this big IP DNS would also help you to protect against the DDoS attack, because this box is more powerful. So all your requests are not going to your backend servers, because the DDoS attack is one of the known attack onto DNS servers, right?
Yeah.
Due to DDoS, you must have heard the due to DDoS, the DNS server went down, right?
Yeah.
Due to DDoS attack. So the big IP DNS is enough or is a capable device to handle the DDoS attack, right? Because it has a capability to accept the millions of requests per second, right? And it will not go down. So even if there is a DDoS attack, right? So ideally, most type of the DDoS attack can be handled easily by the big IP DNS. It will not go down. That is another advantage of placing the big IP DNS. Like,
Okay.
but it's big IP is expensive device, so it's not like easy for most organizations to utilize.
And I have one question
Yes.
for this lab setup, for this topology. What is the requirement, hardware requirement?
Ah man, I mean that's really bad. Is
No,
so
because I
it
have
has got so many devices.
no.
So let
I
me tell
have
you.
Blade server at my place.
Okay, okay,
It
nice.
is having
So
256 GB RAM.
nice. Then it can work. 256 GB RAM and then only 16 CPU cores. And if you have got 32
I
CPU cores, it would
I
work.
have 32 CPU core, 30. I think I don't know, but I have that kind of Blade server with me.
Maybe you
It's
have got 16 physical cores and then 32 virtual CPU cores.
I
So it
think
should work perfectly fine.
24 physical. I think I have.
Then you should have 48 virtual CPU cores.
Yes, yes.
So then it is more than sufficient, right? So you can have it. So you can engage the F5, sorry, you can engage I-MEDITA team. They can have this installed on your machine, the
Yeah,
event.
because I have a lot of things in my machine like Palo Alto, F5
Uh-huh.
FortiGate, SRX as well,
Mm-hmm.
ASA server, ASA, Cisco ASA, a lot of things, and even though Kali Linux, lot of things in my that server because I need that thing to prepare the POC for the customers.
Mm-hmm. Mm-hmm. Nice. So you can also draw, I mean, you can have it right on your server. So it is not a big task.
Okay, okay,
Yeah. So um, I have like these three servers in DC1 and then three more servers in DC2. I've got
okay,
one LTM in DC1. This is LTM, correct? And then there is one another DC2 where also I've got LTM. Ideally in production, the LTMs will be in HA, correct? But here
okay.
I'm not teaching you the LTM, right? Therefore, I decided to keep LTM in a standalone, the standalone LTMs, right? Now the application is hosted in both data centers in this example, and then big IP DNS is there. So what I want is that my primary DC is DC1, correct, for the application. So if any client PC from internet is coming to access that application, uh,
Okay.
the, the primary DC is DC1. But in case if DC1 is not available, then the DC2 should be utilized, correct?
Yes.
But we can also do it in a different way. That let's say for India, the DC1 is primary, DC2 is secondary, but for US, DC2 is primary and DC1 is secondary. That can also be done. That is also doable because this F5 big IP DNS is a intelligent DNS server, right? It is an intelligent DNS server, so it can easily identify that request is coming from which region. Like it has got geolocation database, so based on that, it can take the decision where to, I mean, which DC needs to be utilized for providing the application access to the end users, right? So there are so many things that you can play around on the big IP DNS. We're gonna we're going to perform all these things by ourselves. Like we can perform load balancing based on like primary, secondary only. Like this is primary, this is secondary, fine. But then also based on the geolocation, you can change your primary and secondary data centers. That is another thing. But this is how I have set up this lab, right?
Okay.
Ideally, like in this lab, you would see that okay, it looks like Big IP DNS is connected to the internet, but it's outside DC. But it's not outside DC. Consider it that Big IP DNS is also hosted in in each of your DC. Like
Yeah.
there is a sync only group. Ideally, we do not use the failover for DNS services. We don't use that. We don't use failover for
Yeah.
Big IP DNS. What we do is we create a sync only group for the Big IP DNS, right? So when I say sync only, which means that um, if you create an entry on one of the Big IP DNS in DC1, right, then same entry is also created on the Big IP DNS in DC2. No failover is needed because if you have got two different Big IP DNS, then you can use their listeners as primary and secondary DNS server IPs, because on client machine you get primary DNS field and secondary DNS field, right? So you can always provide those IP addresses. So you will have to use them in active mode. So failover is not needed in that case, but you always create the sync only group, so that if you create entry on one of the Big IP DNS, then it also gets created on another Big IP DNS, right, sir?
Oh,
So even the Big IP DNS will be reside in same data center where your LTMs are, right? So, but here just to make it little more easier for understanding purpose, I kept them little away from the DCs, the GTM. So I've got
okay.
one standalone GTM here. This is a standalone GTM, or you call it DNS, right? Any more questions, concerns so far?
No, not it. Not it.
Okay, good. So I think we should continue tomorrow then. If they want to join in, I will ask them to join and then
Yes.
we'll take it further. First,
Yes, sir.
we have to look at the topology. ये देखिए. So between ISP and the Big IP DNS, this is the subnet that we are using 12.1.1.0. So first, let me show you the configuration of this ISP router. So IP interface brief. So the first valid IP address of the subnet is allocated on the ISP itself in all the subnets. So you can see on across all the links, like between customer edge and ISP, I'm using 11.1.0/24. Just a moment. Let me just edit this in bold now so that it's more visible to you. That's more visible. So now you can see like we have multiple public IP subnets between customer edge ISP and then ISP to Big IP DNS. And first of all, I'm going to set up this thing, right? I mean, right there, the Big IP DNS, right? So I'll just wipe this out so that we remove all the existing configuration and we just set this up from the scratch, from zero. And that's what is needed. I will start this. We'll take the console access. So first we will start with the IP configuration. So and then we'll also add the routes uh, as and when needed. Now you would see that Big IP DNS would get started. The Big IP DNS should boot up now. And let me also tell you, these Windows servers are pre-configured, but in your lab, like once you have access to this lab, you will have to get them configured. In lab, these servers are not pre-configured. If you look at the configuration of these servers, let me show you. So you just have to log in there. Let me put the password. So the default password of these servers is, so that's the password for these servers, just for your information. So this is server one. If you go there, the IP address is configured statically. So if you look at the status and details, this is the IP address that we have configured here, right? 50.10. And 50.1 is the gateway. 50.1 would be an IP address that we will allocate on the Big IP DNS. That means that Big IP DNS would be working as a default gateway at same time. So 50.1 would be an IP address of the Big IP DNS. And the server is having that IP address. Now, apart from having IP address, remember that this system is also working as a domain controller. So you need to install the Active Directory, right? DC promo needs to be used, right? Like for an example, if you are running DC promo like this, you run that, you know, run that service, DC promo service, and then get the Active Directory services installed on these servers. Because if you do not install the Active Directory services, then it says that domain controller is a common global catalog server, something like that, right? So you can see that, right? So I'm just exiting. All you have to do is using DC promo, you have to install the Active Directory services. Along with Active Directory services, make sure that you are also enabling the DNS services, because the ultimate goal is to configure this server as a DNS server, right? So that's the ultimate goal. So this is your DNS server. So first you have to do like Active Directory users and computers, right? I mean, it should be displayed. This is the domain name. And then obviously DNS has to be installed. So when you open up the DNS, this is how it would look like, right? So it will have a forward lookup zone. So obviously we have got a forward lookup zone like I-MEDITA.com. And within I-MEDITA.com, I have created a couple of host A entries. Now remember that host A entries are created to resolve your names into an IP addresses, right? So if you want entries to be created on your server to resolve your names into their respective IP addresses, then go ahead and create the host A entries, right? So this is what you are doing here, right? So you're creating host A entries. So you have got HR, and then there are multiple entries, right, for HR, and we have got multiple entries for IT as well, for www as well. So these are the entries, right? So this will be like www.imedita.com, right? So that way you can create as many as entries you want on these Windows servers, right? And apart from that, now log into another DNS server and make sure that this DNS server is also configured properly, right? So let me log in here. But then you can change them. You can change the password as per your own way, right? So if you want to change that, and then the IP address of this machine is 50 dot, in my opinion, it should be 50.20. So yeah, it's 50.20, gateway is 50.1, and then join this machine with the with your existing existing domain that you created on server one, and then also make it DNS server, right? Like you can have DNS services installed on this server as well. So both so both of them, like both of these servers, start working as a DNS server. So that's the objective, right? So like these both servers should work as a DNS server, and then I have replicated the same entries here, right? Ideally, when your both of the DNS servers are in sync, right? If they are in sync, then if you create the host A entry on one of the DNS server, it should also get created on another DNS server automatically without doing it manually, right? So that should happen. But just in case if you are not able to synchronize your DNS entries between the server, do not worry, because your job is not to is not to troubleshoot the Windows DNS server, right? Leave it, just replicate the configuration, right? So whatever you created on server one, just go ahead and create the same entries on server two. That's it. That's all you need to do, right? If synchronization is not happening, do not perform any kind of troubleshooting, right? Fine. Once you have set up these two servers, the next step would be to set up your BIG-IP DNS. And now this is what exactly I am going to perform, right? Hold on. Let me take the console access of this BIG-IP. So as you know, the default username is root and the default password is default. Current password is default, and the new BIG-IP address. No license. Obviously, there is no license, there is no configuration, because I have wiped everything from this BIG-IP, right? So the next step would be now go to, I mean, the first step would be to allocate the management IP. Although it can obtain an IP address from the DSCP as well, right? And it should have obtained actually, if I say. So if I say like TMSH and then say list sys management IP. So yeah, it has got that IP address, which is 1.245. So now it has not actually. Let me see what's, oh, this management switch was not started. I'm sorry. So since this management switch was not powered on, so this big IP DNS was not able to talk to your DNS server. Now it should obtain an IP address from the DHCP. Just give it a moment. Let this switch boot up. And as soon as this switch boots up, in my topology, it can obtain an IP address from DHCP, but in your topology, it will not be possible. So you will have to allocate IPs manually, and there will be a jump host. From that jump host, then you can have access to your all of the big IP systems, and then jump host will also have the internet access at same time, because it would have like multiple NIC cards, and from there you can also install the license. So now if I go back here to this big IP system, just wait. Okay, description is static fallback. So it has already fallen back to the static IP address. Let me do one thing then. I'll just say modify sys management IP DHCP. Oh. So now that is a problem, that it has obtained an IP address statically, like the default IP address that it has obtained now. List sys management IP, you could see that, right? So all I have to do is modify sys global settings, and then it should have, it doesn't have that option as well now, since it has fallen back to the, oh no, it was modify sys global settings management DHCP enabled. Just a moment. List sys management IP. Yeah, now it has obtained the IP address as soon as I executed that command. So the command that I executed was, let me show you, right? So this is the command, modify sys global settings DHCP enabled. Because what happened was, when we boot, like whenever you boot up your big IP system, it tries to obtain an IP address from the DHCP server. It tries to obtain an IP address from DHCP server. But if it is unable to obtain an IP address from DHCP server, let's say DHCP server is not online, or is, it's down due to some reason, then the problem would be like, it will fall back to the its default static IP, and that's what exactly it did. So if you look at the IP address, what is obtained before was 1.245. That's a default IP address. So that's what it obtained, IP address. But it was a kind of a static fallback. That's a default IP address. So if DSCP is not there, just I'm just telling you, let's say you do not want, you don't have the console access of the big IP, or maybe you lost the console cable, or you don't have the console cable available, and there is a brand new big IP. All you have to do is either you should connect your big IP to a DSCP network, where you could see that, okay, a new IP address was released from the DSCP server, and then you can also compare the IP against its IP addresses, because on a switch you can easily find the MAC address of big IP. Or the other thing would be, if you don't connect your big IP to a DSCP network, let's say there is no DSCP available, all you have to do is just wait for some time, and then that would be the default IP address of your big IP 1.245, right? And then allocate an IP address from the same subnet to your laptop, and connect a direct cable, a Ethernet cable from management port of the big IP to your laptop. And that way, you would have management access automatically from your laptop to big IP, and then you can log in onto your big IP using CLI, using GUI, by leveraging its management connectivity. So in short, I would say that in case of the big IP, you do not necessary to have the console cable all the time when you try to bring up your big IP very first time. So console is not mandatory. Like in case of Cisco, it is mandatory, right? In most cases. But here in big IP, here in case of big IP, it is not mandatory. So that's that. The next thing that I would say now is to allocate IPs and all that kind of stuff, right? So I have to get the list sys management IP. So get that IP address now, 215, and then have it access on your system. Admin, and then the password. Obviously, first time your admin password is also marked as expired, so you will have to change it immediately. Save. So this is the initial setup. Say next now, and then say activate. I have to activate the license, right? And I have got a license key actually, right? I have to use them. So Big IP Virtual Edition. This is the one that I'm going to use now. So I'm going to use that now. So registration key and then say manual and then say next, so that we can get the dossier file, and then we will just go to the licensing server and we'll get this activated. So I mean the process till now is same as the Big IP, the LTM module that we covered in past. There is no single difference. Click for accessing the licensing server, copy your dossier, paste your dossier, say next, accept the end user legal agreement, and then you should get the licensing file. There you go. Copy that, paste it back on your Big IP, and then say next. And that way license should get installed on your Big IP. So this process is 100% same as before. There are no changes actually. So now this time I don't need LTM. So just uncheck that, right? And then select the DNS, right? You should have GTM Global Traffic Manager. So there you go. Select that and then say dedicated, right? That way it will get rebooted, but that's okay, right? So select the dedicated, right? GTM and then say next. Say okay. Obviously it will get its services restarted, but that is all right. And that's what we are doing now. Continue. Say next. I don't have to change the device certificate at this moment. So, I mean, this whole process is same as before. I'm not doing anything extra. So now host name is, this is DNS, right? 1.imedita.com, correct? That's the host name that I'm putting here. And the root account is like root password, right? I have to put it on. That's mandatory, or get it disabled. So it's up to you. But this is what I have done here. I've just allocated host name and put on the root password. And then after I'll have to allocate IPs. So I have to configure 1.1 and 1.2. So I need two VLANs because without creating VLAN, I cannot really configure the IP addresses, right? So I have to configure, I have to create the VLANs for 1.1 and then 1.2. Get this finished. And then after you go to network and then go to VLANs, just create the VLANs. So let's say I'm just creating the external VLAN first. So which is VLAN 10 and then VLAN 10. And the interface that I'll be using here is 1.1, correct? This is the internet facing interface. So untagged because I have access port at other end. I don't have trunking, right? So that something needs to be done. And then say internal VLAN, let's say 20, correct? The tag is 20, 1.2 untagged, add, finished. Once you're done with that, then go ahead and create the self IPs, right? So create, name is external IP, and then IP address is 12.1.2, 12.1.2, and then subnet mask is 255.255.252, or maybe, okay, this is on /24. So I have to say .0. And then external VLAN, which is correct, allow none. We can keep that for now, which is okay. And then repeat. Now internal IP. So internal IP is going to be 50.1, 192.168.50.1, correct? So 192.168.50.1/24. Then VLAN is internal VLAN, and that's it. Get this finished. By default, there was a allow none. I kept it. Under routes, I must add a static default route pointing towards the internet, right? So I would name it default route. Destination is like 000. Net mask is 000. The gateway is going to be 12.1.1. That's the gateway. So get this finished. So default route has been installed. Now validate that configuration using CLI. So list is okay. List NAT VLAN. VLANs are created. Then list NAT self IPs. Good. List NAT route, which is also good. Now show NAT route. I shall have the default route. I have that. And then show NAT self. Yes, the interfaces are created. Interfaces are up, which is good. So now we are done with the basic configuration, correct? Now remember that by default, your big IP DNS would not be accepting any of the DNS request. Like there is a DNS module. You see that all these things are there, GSLB, zones, right? So all the DNS related configuration will be done under the DNS tab, right? So if you expand this DNS tab, similar to like what you had for local traffic for LTM, right? So for LTM, you had local traffic. For DNS, for GTM, you have got this DNS tab. So all the DNS related configuration must be done under DNS tab only. So you have got delivery, you have got GSLP, zones, cache, settings, the global settings. So if you are looking to configure this DNS, then, if you're looking to configure this DNS just to perform load balancing, balancing. So if you're looking to configure this DNS just to perform load balancing for your DNS request, like you're doing some sort of migration. So you are putting just big IP DNS. Earlier you were using only Windows DNS servers, and now you have a plan to put on this big IP DNS in between, in the middle. So all you have to do is you just have to connect. You have to make the connections, make the cable connections, allocate the IPs, make the routing. Once it is done, then after, all you have to do is like you have to make the configuration under delivery. Like so under delivery you get an option to add your nodes, to create your pool, and then to create a listener. Like in LTM we had a virtual server. In similar way we have got a listener over here. Like you have to create listeners. Like currently if you see there are no listeners. So for configuring listener, let's say I've got a dedicated subnet. Although I can use the same subnet like 12.1.0/24, there are many IP addresses which are available, but I decided to use a different subnet. And for that subnet, the routing is already done. Like ISP will send the traffic towards the big IP DNS for this subnet 770/24. Even you can see this ISP is already configured with that static route. So if you look at here 770, and then next hop is 12.1.2. So it's already there. So basically for listeners, for configuring listeners, I'll be using this subnet, which is 7770/24. So that's what I'll be using. Then the next thing would be now to add your nodes. So if you want to add your nodes, so I'm going to use this DNS as a LTM initially. I just want my big IP DNS to perform the load balancing. So it just, it receives the DNS request and it works then as a proxy, right, for the DNS request. And then it forward those DNS requests over to these backend servers, and it just should perform the load balancing between them. So as of now, if I use, let's say, I've decided to configure a listener with IP address of 7.7.7. Let's assume that. Okay, what I'm saying is that let's decide to have this IP address on listener 777. It's like virtual server. Earlier, like on LTM, we used to have the virtual servers, but here in DNS, we have got a listener. So let's use that. So that public IP address, I'll be allocating directly on big IP DNS. Although in production, this is not how you set this up. Ideally, your static net would take place maybe on firewall or maybe on a router. And then you would be creating a listener with a private IP address internally on your big IP DNS. That's how you do in production. But since we are not covering any firewall, or we are not covering here like how to configure NAT and all that on routers. So I've decided to directly allocate public IP on big IP DNS. And therefore, I have already added a static like I have done the routing, which is okay. Now I have to go back, and the very first step would be to add those servers as a node. So to configure those servers as a node, all you have to do is, what you could do here, you go to load balancing, and then you get those options like creating nodes and all that, You could do that. And also, if I try to reach 7.7.7, because that listener is not created yet, we haven't created that listener by now. So I can't ping that IP address as of now. So if I want to ping 7.7.7, I cannot ping. Remember that this customer edge is already configured with PAT, port address translation. So it will go to internet with its public IP address. So PAT is already configured on this edge router. So I can't access that IP address. I can't ping. Why? Because listener is not in place. However, if you go and create a listener, let's say you just go and create a listener. So that, let's say this is DNS listener one, something like that. And then the IP address of the listener is 7.7.7. That's the host. And then UDP is protocol, which is fine. And that's it. I'm not associating any pool as of now. All I want to show you that if you create a listener, just provide a name and IP address. That's it. Get this finished. As soon as you do that, you create this listener IP or this listener object, then after you should be able to ping that IP. See, so now you are able to ping that listener IP address, and that's what you were supposed to have. So you were supposed to ping this listener IP address. So yes, we were able to ping this IP address now here, and now, since we have created and we have already created this listener, but it's not doing any kind of like resolution as at this moment. Why? There is no I rule associated with that. There is no pool associated with that. So it's not able to take any decision. So for an example, if I go to that lane user machine and let me configure that IP address as my DNS server IP. So listener IP should be your DNS server IP for the lane users. So if I say like IP config, so IP config is like having IP address 1.10, and then 1.1 is gateway. But then look at the DNS server. So say all. So now you can see that 7.7.7 is configured as DNS server. So that IP address is working as a DNS server IP address. That's that IP address 7.7.7. And then if I go back to my PC and try to look up, like let's say if I say, hey, ns lookup www.imedita.com, can I get that resolved? No. So query was refused by my listener. You know why? Because there is no pool associated with the listener. There is no I rule defined so that it could perform like by the help of I rule, it could resolve. But now let me create a small I rule, so that you are more comfortable that how things are working here. So what you could do, there is a small I rule that I could basically create here. Now let me show you the I rule that you could create here. Just a moment. Oh, again, it has gone back to the default one. So let me go to full screen mode. So listener, so you know that how to configure that listener. So I'm going to create this listener, which is fine. We have already done that. You could also do it using the CLI. You already have this guide available on your portal. So you can also look for the CLI command. I can also go ahead and create using the CLI, but yeah, I mean, it's the same syntax. So I don't really have to do it. You can do it by your own. So all I want is like it should perform the resolution based on let's say I rule, based on I rule. You can do that. All we have to do is we just have to configure that I rule where we should say that, hey, if you get any DNS request, then you should provide a response back. And in response, you should provide this IP address, right? So you can configure that in that way. Just a moment. I'm not able to find that I rule here. It's a very small I rule. This is all you have to do. This is how you create the simple I rule. It's very simple I rule. So for an example, if you say delivery and then go to I rules. Now remember that also you get I rule under GSLB, but don't create I rule under GSLB because I want to use that I rule under delivery. So you go to delivery and then say I rule, and then there is a I rule list. And if you look at there, show all, so you get all of these I rules there. So just say create and then just paste that. So all you have to do is you have to save in, and this is a DNS request. And then all you have to do is that you just have to provide the host IP address, which is, let's say, in response, I want to provide this IP address, let's say 50.50.50.50, let's say, right? And that's it. Just name it like DNS I rule 1, correct? So a very, very basic I rule has been created, right? So it says that host 50.50.50 error undefined procedure host should take that. Is there anything? Oh, DNS request. Yeah, this is all good actually. Let me try to create that over here. When DNS request and then code is like host. And then let's see if I'm saying 50.50.50. and this is I rule DNS testing. Yeah, it has accepted that here. Then what was the problem that I made over there? Let me see if I can have that I rule over here now. No, I don't have that I rule which I created over there. So ultimately I have to create that under delivery. So I think let me try to do that again, right? So test DNS I rule. Although I don't have to create that, but I'm just trying to create to show you that I can have a simple host. Let's say 5.5.550 like this. Then let's finish this. It's not taking that actually. I don't know why. Over here. And the same syntax I used. Okay, leave it then. So I just want my big IP DNS to perform the load balancing between these two backend DNS servers. So all you needed to perform was go to load balancing like under delivery only, under delivery. Because if you go to GSLB, then you go to intelligent DNS resolution. So that's a separate topic. So don't go for this GSLB. Initially, just work around delivery only. So first you have to create the listener. In fact, before creating listener, we must have created nodes and then pools, all that kind of stuff. So let's create the nodes, right? So create, say, DNS server 1 like this. The IP address is 50.10. Repeat. And DNS server 2 50.20. Finished. We have created the nodes and then go to load balancing, create a pool. So create, you have to name it, say DNS server pool. Let's say we are using gateway ICMP for monitoring. The default load balancing algorithm is same as LTM, which is round robin, right? Then I add the nodes from the node list. So server 1 port is 53. That should be, yeah, DNS is not there, right? So just type in manually. So 53 like this. And then add server 2 as well with port 53 like this. You could select any of these load balancing algorithms which you have right in front of you, right? You could select any of these load balancing algorithms, right? And then get this finished. So this is the DNS server pool that we have created. And then go back to your listener. Your listener is having an option to associate a pool, right? So over here, if you go to load balancing, you get this default pool option. That's where we will create that pool. And now this pool is available. You can see that. In fact, if you go back to listener and then load balancing and then pool, the status of the pool, and then also under listener, if we go to listener and then go to load balancing, you would see that this pool is available, right? I rule is not applied. We haven't applied any I rule so far. But now, what should happen is that if DNS request is coming to this big IP DNS, then it should forward them onto the backend DNS servers. It should happen automatically, right? We should not require to do anything extra for that, right? I'll do it now. So if I say like NS lookup, this NS lookup should get completed because we had that WW entry, right? But still it's not working, right? So if it is not working, then you need to perform troubleshooting. So first, see if your traffic is really hitting, the DNS requests are really hitting to your listener. So go back to your listener now. And for this listener, just look for the stats. So if you see any request, so yes, we are receiving packets in and out, right? So we can see how many total requests we have received so far. So 33 total responses were given 23, right? The rate limit per second, right? Says that's the rate limit which is currently applied. And host A query for host A that system has made so far is 27, right? The pointer record and then 4 times says for IPv6, right? So you can see all that detail, which means that yes, the DNS queries are coming here, right? There is no question around that, right? But is it sending them over to the backend servers? And that's something that you need to see that. I mean, you need to see if you are really forwarding them, like big IP is really forwarding them onto the backend server. So let me tell you one thing here, right? So, I mean, obviously it will perform the load balancing, but by default, like in LTM, destination NAT takes place automatically. Remember? On LTM, like when the pool member is selected, then destination IP will always get translated into the member's IP address automatically. You don't do anything for that. But if you talk about the DNS, right? The GTM, right? Global Traffic Manager, right? If you talk about this, by default, it doesn't do that. It doesn't do that. It doesn't translate the destination IP. If you want it to translate the destination IP, then you have to do one thing. You have to make a change over here, right? So you go back to listener, and then for this listener, you go to like from basic, you go to advanced, and then there is a address translation, right? Source address translation is also available if you want to perform a SNAT, but this is destination NAT, right? So get it enabled like this. And as soon as you enable the address translation, then yes, everything would work fine then, right? So I have enabled now destination this address translation over here, right? As soon as you do that now, right, you go back to your test user machine and then perform DNS lookup once again, right? And yeah, you got it now, right? You have got the answer from the DNS server. So you got 555 and you got 6.6.6, right? If I do it again, so earlier 6.6.6 was primary and 5.5.5 was secondary. But now you can see that 5.5.5 is primary and as part of the DNS response. So every time like you get it, like you are getting the same IPs, but primary, secondary is a different because by default your Windows DNS server provides the responses based on round robin method, right? Because on the backend DNS server, you have both entries created, right? So if I go back to DNS here, you see forward lookups on for www.imedita.com, I have 5.5.5 as well as 6.6.6, right? So it will provide both of the IP addresses, but every time the primary and secondary IPs will be different in round robin fashion by default from the Windows DNS server. So you're getting these responses coming back from Windows DNS server. In fact, SNET can also be enabled just in case if default gateway is not configured on backend DNS servers, right? So if the default gateway for backend DNS servers is not big IP DNS, then you could go ahead and you could enable the source address translation using automap. That is also possible, right? So you could update this now. And as soon as you do that, then again, it should be working, even if you remove the default gateway from backend servers, right? So that's what you could perform using these available options. Does that make sense? So this is how you could play around the listener IP address. So creating this listener is mandatory. Without creating listener, your big IP DNS is not going to entertain any of the incoming DNS request. So listener is created, node have been added, pool is been created, pool has been associated with the listener now. And yeah, it's performing load balancing as it should. But the next chapter, because we have learned that how to create a listener, but next chapter that we need to cover is now like how to accelerate this process. I mean, this name resolution, right? So that's the next chapter, very next chapter that we need to cover, right? Acceleration of the DNS resolution. Now, one more thing, this is a chart which is given, right? This is how the DNS queries are processed by the big IP, right? So we should be aware with that, right? So if a DNS query is arrived on a listener, the very first thing it would check is the wide IP. So it will check if there is a wide IP, right? If wide IP is not created, then only it will go for the express zone. If there is no express zone configured, then it will look for the cache, and that is like again, if caching is not enabled, then it will look for the resolving cache. If resolving cache is not there, then it will see if there is a pool associated with this listener. And this is exactly what has been used in our case, right? We associated a pool with the listener, and that has been utilized by the big IP DNS to perform the load balancing. So this is exactly where the decision was made by the big IP DNS in our case, right? Because we have not configured any wide IP. We have not configured any DNS express zone. We have not configured any the caching, right? And also we have not enabled any resolving cache, right? The only thing we configured was a pool and associated that with the listener, and that's how listener got the DNS requests load balanced among the pool members. So that's what has happened.
No, not yet.
Now, for us, it is important, to remember all these steps, right? Because let's say you have configured caching and you have configured express zone both. And if the DNS request was received by the big IP DNS, then remember that express zone will be preferred over the caching. Okay. And let's say there is a wide IP created and also you have an entry in your express zone, right? Then wide IP will be preferred by the big IP DNS, right? Because as soon as it founds the object in a sequence, right? So first, um, the priority will be given to the first match, right? So if something matched with wide IP, then a resolution will be provided or response will be given based on wide IP only. But wide IP, we have not discussed about the wide IP so far, right? We haven't discussed about the intelligent resolution so far, right? So we just started with the pool, and this is exactly where our load balancing happened, right? So this is the step that we have completed so far. Now the next step is to understand that how we can, listener, we got it created, right? We have already done that. Address translation. So as I told you, this address translation setting determines whether or not big IP system will translate the destination IP address on a proxied connection, correct? So as I told you before that in LTM, destination IP gets translated automatically. You don't do anything extra for that. But over here in DNS, it doesn't do that because by default, address translation is not enabled, right? So you have to get it enabled. And if you don't get it enabled, then the backend DNS servers would receive obviously your DNS request, but they will simply drop your data, drop your packets, because whenever any machine receives a packet, receives an IP packet, destination IP must match with its own IP address. If it doesn't, then it will simply discard that packet, right? So I had to get this enabled to make it work, right? Anycast listener is nothing but obviously you can have your a listener like a same IP address from both of the data centers. That's Anycast listener. So in case if let's say, and then you can play around with the BGP, right? Border Gateway Protocol, and you can make any of the data center as your primary data center. And if that goes down, then you have the same IP address coming from the another DC, and that's exactly Google is doing. This is exactly what Google is doing, because 8.8.8, it doesn't go down. It goes down only if all of their data centers are down or there is a problem from the service provider end, let's say. But yeah, you can have the Anycast listener, where you would have your listener IP address getting advertised over to the internet from multiple data centers. So you could use the dig command, but I'm not going to use that as of now. That's not supported. Only NSLOOKUP is supported in my lab. So listener is being created. We have done that, and then we have also created a server pool. And this is exactly how it works then. So you send a DNS request, DNS query to your big IP DNS. Big IP DNS is working as a proxy server for your DNS request. It will stop those DNS queries and then will get them forwarded over to the pool members, selected pool members. Configuring DNS query load balancing. So we already did that. You know it. The load balancing algorithms could be like round robin or, like ratio. There are many options similar to what we had in LTM. And then monitoring is also there to monitor the pool members. So we did that. So load balanced DNS queries, we have done this. So this is all done. So you can create a monitor, and this monitor is basically based on the DNS only. So this is DNS based monitor. What you are doing is you're asking your each of pool member to resolve what DNS queries. So as long as you are receiving the DNS responses coming from the backend servers, you're good, right? Like that server is working okay, the DNS server is working okay. Would you agree with that statement? So I just used like ICMP, but technically I should have used, like in production, we should not use, we should not be using like ICMP type of monitoring. Instead of that, we should use DNS based monitor. Like you can go here and then you can create one like DNS monitor like this, and then your base monitor should be DNS, right? Select that. The query name is like www.imedita.com, correct? And as long as I'm getting an IP address is like 5.5.5, query type should be A. So we are good, right? So get this finished. And then go back to your delivery and then load balancing and then pool. So on pool, I apply it like ICMP type of monitor, but let's apply the DNS monitor, which I have just created, and then get this updated. So DNS monitor. So now what will happen is that periodically BIG-IP will keep on sending DNS queries to my pool members. And as long as it receives that string which are defined in monitor, which means that yes, the backend servers are working perfectly okay. Correct. Would you all agree with that statement? Because members will always inherit the monitor from the pool. Although you can also configure like member specific monitor that is also available technically, but it's all up to you. The next thing that we are going to cover is to accelerate this performance. So if you want to accelerate the DNS resolution, so modify listener to support load balancing query. So I have already done that. So translate address was needed to be enabled. If you don't get this enabled, then your DNS request doesn't go through. So dig command you could use, or NS lookup. We used NS lookup. That is good. Now the chapter number 3 is accelerating DNS resolution by enabling the cache. So when you talk about the cache, there are 3 different types of caches supported by your BIG-IP DNS. One is transparent cache. The other one is resolver cache. The third one is also resolver cache with validation. So it's like, again, it is a resolver caching. So technically there are 2 types, but yes, because third one is slightly like there is a slight difference between second and third, right? So again, we are considering them like technically we are considering them 3 different caching types. Ideally, you use only transparent caching. Yeah, resolver caching is something different. I will let you know that how resolver cache works and how transparent cache works. So in our case, we have got a use case of the transparent cache. So this is how the transparent cache would work, right? So let's say when you sent a DNS request to your BIG-IP DNS listener would receive that. And if there is no cache, like if there is, if caching is enabled, it will always first check if it has that record available in its cache. If there is no record available in the cache, then it will perform load balancing, will select the pool member, and then request will be forwarded to any of the pool member. Then pool member will send the response back. But since your BIG-IP DNS is now working as a proxy, right, it is proxying the DNS request and responses. So it will proxy the DNS response and will create an entry in its transparent cache, right? So it will create an entry in its cache and then will forward that response back to the client. Now, in future, if it gets a request coming in, then it will provide the responses back from its cache. So there is no need to forward those DNS requests onto your backend server, and that way you are saving the resources on your backend server. Would you all agree with that statement? That yes, you are saving those resources now. Good. So this is transparent cache, and we have got exactly same, the same scenario over here, right? So we can enable the transparent cache here, but before I enable the transparent cache, let me also talk about the other resolver cache. So resolver cache will be used by the BIG-IP DNS if like the transparent cache was used in that case where you had your internal DNS servers sitting behind the BIG-IP DNS. But let's say you are using your BIG-IP DNS as a LDNS, local DNS for your internal lane users for your organization, right? So it's been used as a LDNS. So sometimes you would see that your BIG-IP DNS is not having the entries in its cache, or maybe like on the internal DNS servers, like for especially while accessing the internet. Your BIG-IP DNS would have to follow this step. Like first it should go to root server, then the TLD server, and then from TLD, then it will get the domain server or authoritative server IP address, and that's how it resolves them. So if you are enabling resolver cache, then these records will also be cached by the BIG-IP, right? So for this kind of scenario, you have to get the resolver cache enabled, right? Where you are utilizing your BIG-IP DNS as a LDNS, local DNS. So if you're sending DNS request over to internet and then you want to cache the responses coming from the internet DNS servers, then yes, you have to get this resolver cache enabled, right? But in our case, we don't have such case, such condition. All we have got is the backend DNS server, and I want to cache the responses coming from those backend servers, right? So that's what I want to do. To do so, you have to enable the transparent cache, and this is exactly what I'll be doing now, right? So if you want to enable the transparent cache, it's so easy. Enabling transparent cache is so easy, right? So if you want to configure the transparent cache, the very first thing that you have to do is, like, you go back to BIG-IP DNS, and then there is a cache, and then go to cache list. So there is no cache list created. So first we have to create that. So I'll just say that this is my DNS and this is transparent cache, right? Transparent test cache testing. Type should be transparent this time. This is what you have to do, and that's it. That's it. All this is all you needed to do. So finished. You named, like, you created that with that name. Then you have to get it applied, right? You have to get it applied. But there is no way to get it applied directly on a listener. So like if you go to listener and then if you want to apply, like we are under advanced only, right? We are under advanced here. If you see here, I don't see any, like even under services, if you go to advanced, right, you don't get any option to apply the cache list over here directly to your listener. So that's not possible. Then how can we enable this caching on your listener? Because ultimately it has to be enabled on your listener, right? So if you are looking to enable your caching on your listener, you can't get this enabled directly, right? If you want to get this enabled, then you have to get this enabled through your DNS profile. So you see that there is a profile, right? The profile is already there, the DNS profile, right? It's already there, DNS. I can't modify. This is system generated profile, so I can't modify that. Instead, I have to create one. So go to profiles, delivery, profiles. Again, you have to work under delivery only, because under GSLB also you will get this option to create like all those sort of things, right? So you have to go to delivery and then go to profile and then go to DNS profile. So DNS is already there. Now create a new one. The parent profile would be the DNS profile only, but now name it like test DNS transparent, right, profile, right? Now it will give you an option to enable the DNS caching, right? So enable the custom options, enable DNS cache in this profile. So enable it and then call out your DNS cache name. So this is exactly what I have created. Get this finished now. Once you get this finished, then go back to your listener and modify your listener with this DNS profile that we have just created and get this updated now. Once you get this updated, then after, first of all, I would like to show you that if there are any entries, right? So if you want to see them, right, that if there are any entries, then let's do one thing. Using CLI, you can run this command like show LTM DNS cache and then transparent, and then there was a name of transparent cache, right? So if it has been created and if it is it has resolved any it has provided any response through this transparent cache, so it's 0, right? The answer locally is 0. And if you want to look at the records, right, so the command would be show LTM DNS cache record, right? Oh, come on, records RR set cache and then DNS transparent cache testing. So 0 record, right? Fine. I'll go back. I'll use the NS lookup once again for www.imedita.com, right? Now, if I see that if there was a response given locally, nothing, 0. But if you look at the cache entries now, I have seen that those entries are available now. See, correct? So in cache, it has created those entries. So going forward, if you execute like NS lookup multiple times for the same domain, you would see that now it would provide the responses locally from its cache. So see that. So the command that I have executed here now is show LTM DNS cache, show LTM DNS cache transparent, and then cache named. So it says that answered locally 8. So that clearly indicates that using caching, it has provided the responses. So that clearly indicates now. The command syntax that I used here to see all these entries Let me show you that, right? So this is the command to see if there is a record in its cache. And the second command, like this one, to see if the responses are given using the cache, local cache. So this is how you enable the transparent cache. And this is how the big IP would be providing responses using transparent cache. Now, remember that, like if you look at the transparent caching, like records in your cache, so this is decrementing 3495, 3493, and then you can see it. So by default, it was like 3600 seconds. That was 3600 seconds, which is 1 hour. That was the time that we have got for, like that was the TTL, keep these entries in its cache. So that's what we have done now. If you see any problems, or if you want to discuss anything more about this, please go ahead and ask the questions. And if you go back to cache, in fact, you can go to statistics to see if anything is happening. So see, using this cache list that we created, the 8 responses have been given locally, and that would get incremented if I run the NSLOOKUP command again. Refresh it and then see, now it's 10. It's not 8. It's been incremented. So that's what you could see. Again, you go back to cache list, and in fact, you go to settings and then cache. I'm going to settings and then cache. Delivery general. This is about the delivery and general settings. Well, leave it for now, right? So you got that how to enable the caching, right? And we also have proved that yes, using caching, the big IP DNS was able to provide the responses locally. So that's how you could improve the DNS resolution process, or you could have faster DNS resolution. Although you still have the backend DNS servers, it's not like you do not have backend DNS servers. But yes, this big IP DNS has created a cache, an entry in its cache, and then yeah, this is what has happened now. Good. So this has been done now. The next step for improving the DNS resolution or this performance of the DNS server is even to transfer the DNS zone database from the DNS servers to this big IP DNS. So that can also be done. Like we can transfer the zone database, because your DNS servers are having the zone database, and we saw them. Like if you go to one of the big DNS, this is zone, forward lookup zone, and this is what it has within that zone. So this is known as zone database.